So today we're going to look at graphs of trigonometric functions. So the first question that we're asked to look at is, we're asked to graph the following function, y equals 3 times sine theta plus 2. All right, so the first thing we're going to look at is the graph of the function sine theta. So we're only going to consider one period just to make things easier for ourselves. So let's see what the graph of sine theta, y equals sine theta, looks like for one period. So what is the period of sine theta? It's 2 pi or 360 degrees. Let's do this one in degrees. So 360 degrees. They're going to mark off quarters. So every 90 degrees, so 90, 180, 270, and 360. Again, starting at 0. So the maximum or the amplitude of the sine function is 1. So what does our sine function look like? So when theta equals 0, sine is 0, and theta equals 90, sine is 1. And then just follows a nice pattern here. So let's just draw this in. So everyone's seen this. Good. So now we're going to apply the various transformations. Our first transformation is a stretch in the vertical direction by a factor of 3. So let's scroll down and give ourselves a bit more space vertically. Okay. Again, let's mark off our quarters of 0 every 90 degrees. And now our amplitude is 3. We've stretched everything by a factor of 3. 1, 2, 3. So now our vertically stretched sine function, let's try a different color. It looks like this. Not the prettiest graph. All right, so this is y equals 3 sine theta. Let's put our axes in there. I think I might have labeled the one above incorrectly. Let's change that. All right, and this is our parent function, or just basic sine theta function. All right, and our red curve is stretching our sine function vertically by a factor of 3. So what do we do next? Our next transformation is a vertical translation up 2 units. So let's do that. So let's go back to our red curve here. This is y equals 3 times sine theta. Let's scroll down, and we have just enough space. Let's draw another set of axes. Okay. And again, we're going to mark off our quarters or every 90 degrees. Good. And now we're going to move that red curve. Let's take a look at it. We're going to move that red curve up, every point up 2 units. So everything is going to go up 2 units. So if we go back down, let's draw that in. So we need to put some blue one. Okay, so I believe our highest point now is going to be 5. So our axis, so this axis here about which everything oscillates, I'll just do it in yellow, that is going to move up 2 units. So let's start with that. So originally it was at theta equals 0, but now it's moved up, or rather y equals 0, so now it's moved up to y equals 2. and everything oscillates. Our entire function oscillates about that. So our amplitude is 3. Good. And now our function, what does it look like? It looks very much like the red curve, except now everything has been moved up 2 units. So this is our function, y equals 3 sine theta plus 2. So this is the graph of our function, y equals 3 sine theta plus 2. Good. So that brings us to the end of our session today. So if you have any questions, give us a shout at info@raisedbymarks.com or give us a call day or evening. Thank you for watching.